Welcome to our video, and before we would start, don't forget to like, share, and subscribe. Thank you very much. And our topic for today is still about arithmetic sequence, and this is the third part of our video. And we have the objective: find the sum of terms of a given arithmetic sequence. And now, let us have the formula on finding the sum of terms of an arithmetic sequence. Let us have this agreement. I would read the formula as easy as I could. I would not read it in a difficult manner so that our audience, people who are watching this video, could understand it easily. Okay? So let me read the formula in an easy way. Okay? So now we have S over N, which is our sum of terms, is equal to N over 2, where N here refers to our number of terms, to be multiplied by the sum of our first term and our last term. As you can see, A sub 1 here is our first term and A sub N is our last term. And now let's proceed to our second formula. So we have the sum of terms is equal to N over 2 to be multiplied by 2 A sub 1, or twice the first term, plus the quantity of N minus 1 times D, where N is our number of terms and D is our common difference. Now, since we have two formulas, the question now is, what would we use? And when would we use these formulas? Okay? So right now, let's answer those questions. And for us to be clarified what formula we would use. So for the first one, we have, for our sum of terms is equal to N over 2 to be multiplied by the sum of the first term and the last term. We would only use this formula if there is our last term. Now, as you could compare this to the other formula is quite long, right? So if we would choose among the two, then therefore, of course, we would pick the formula that is easy to memorize. But then again, we can only use this formula if there is a last term. And now, let us have our example. So our example: find the sum of the first 28 terms of the sequence 3, 11, 19, 27, 35, ... 219. And as you can see, we have the ... here. It is our ellipsis, and our ellipsis means through or up to. So we could read this as from 35 up to 219. So since our ellipsis is in between two terms, then therefore this example is a finite arithmetic sequence. So now let's start, and since we have our last term, then therefore we would use this formula. So we have the sum of terms is equal to N over 2 times the sum of the first term and the last term. And let us substitute the values. For N, for the number of terms, that would be 28. For the first term, as you can see, our first term is 3, and our last term would be 219. We become 28 over 2 times the sum of the first term, which is 3, and the last term, which is 219. Then, let's apply the indicated operations. So let's follow GEMDAS. The first one would be 3 plus 219, and that would be 222. Then, let's continue. So actually, this is interchangeable. You could do the multiplication first, or you could do the division first. In our example, we had the division first. So that would be 28 divided by 2. That will be equal to 14. So now we have 14 times 222. and that would be 3,108. Okay, so now we have the sum of our first 28 terms of our given arithmetic sequence, and that would be 3,108. And now, let us proceed to our next formula. And we have the sum of terms is equal to n over 2 times the sum of twice the first term and n minus 1 times d. So when would we use this formula? Okay, take note, compared to the other one, this is the longer formula. Okay, so when would we use this one? We would use this one if there is no last term. Okay, so if in our problem there is no last term, then we would use this formula. So now, let us have an example. Find the sum of the first 28 terms of the sequence 3, 11, 19, 27, 35, and ... And here's now our ellipsis. Now, if you could see, our ellipsis is after the last term in our sequence, the 35, and then we have now the ellipsis. This means that our arithmetic sequence is an infinite sequence, meaning it could extend throughout, okay, up to the positive infinity. This is the meaning of our ellipsis here in our problem. So now, let us continue on solving, and let's use our formula. The first thing we would do is we would substitute the values. So for n, that would be 28. For the first term, that would be 3. As you can see, this is twice the first term, then therefore that is 2 times 3. Plus, n here is the number of terms, 28, minus 1, and the common difference is 8. So how did we find 8 as our common difference? We just simply subtracted the next term to the previous one. Like for example, 11 minus 3, that would be 8. 19 minus 11, another 8. 27 minus 19, it's 8. Now, if you have problems on finding the common difference, you can look into our previous videos on how to identify the common difference. Okay, and now let's continue. Now, let's apply the designated operations. So we have, for the group, we have 2 times 3, that would be 6. And then 28 minus 1, that would be 27. And let's continue. So 28 divided by 2, that would be 14. To be multiplied by the sum of 6 and 27 times 8. And 27 times 8, that would be equal to 216. And let's continue. Let's add 6 and 216, and that would be 222. So now we have 14 times 222, and that would be equal to 3,108. So to sum it up, we would use our first formula if there is a last term, and this second formula if there is no last term. And by the way, if you do not want to use this formula because you feel it's too long to memorize, then you may find for the last term first, or rather than you may find for the 28th term first before you would use the other formula. And I guess that would be all for today. And thank you so much for watching our video. And we still have our part 4 for arithmetic sequence with the objective solving problems involving arithmetic sequence. And God bless you all. Thank you.